Greetings and welcome. Today we're looking at radical expressions. We're going to be talking about adding, subtracting, and multiplying them. And I've already done a little bit of work with my class, so this is kind of a part two. So let's just start right off with an example. What if I wanted to simplify the expression 2 square roots of 20 minus 2 square roots of 45 plus 3 square roots of 80. Alright, now in order to combine these as, say, like terms, like radical terms, I guess, need to have identical indexes and identical radicands, so the insides have to match. So currently, all of these do have the little invisible 2's, little hobbits wearing rings, as their indexes, or indices. That doesn't matter. However, they don't currently have matching radicands. So let's see, let's just start by simplifying each term any way we can. So first of all, so let's see, these are square roots, so I'm interested in finding a perfect square that goes into 20. And I believe 4 goes into 20 5 times. Let's see, this next one, is there a perfect square that goes into 45? I believe that's 16. Nope, I lied, 9. Goes in 5 times. And this last one, I've got the square root of 80, and that one, I believe, is 16, going in 5 times. So let's simplify these. The square root of 4 is 2. I guess I'll write this out. 2 times the square root of 5 minus 2 times 3. That's a minus sign, that's a multiplication. Times the square root of 5 plus 3 times 4 times the square root of 5. So now I just simplify. 4 rad 5 minus 6 rad 5 plus 12 rad 5. So now these will behave like terms, as if this said 4x minus 6x plus 12x. Alright? And I can combine them merely by adding their quote-unquote coefficients to one another. So 4 minus 6 is negative 2, plus 12 is a total of 10 square roots of 5. So that is as simple as it gets. I was able to combine those. Not always will they work out so nicely, but in this case it did. Alright, another example we'll look at. We will multiply two expressions here. So what if I've got 2 square roots of 6 minus 3 square roots of 2, and I'm multiplying that by 3 plus the square root of 2. So here, what I could do is distribute, or FOIL, whichever you want to call it. So I'll distribute the first term to both of those, and then the second term to both of those. And when I multiply, I'm going to multiply the numbers that aren't in radicals, and as long as radicals have the same index, you can multiply their insides and combine them to just kind of like one big radical. So let's see, 2 roots of 6 times 3 would be 6 roots of 6. 2 roots of 6 times the square root of 2 would be plus 2 square roots of 12, right? So I multiplied the insides here to get that 12. Negative 3 roots 2 times 3 would be negative 9 roots of 2. So notice only the non-radical portions get multiplied. And this will be negative 3 square roots of 4, because 2 times 2 became 4. So now let's just see if we can simplify any of this. Is there a perfect square that goes into 6? No, there is not. There is, however, a perfect square that goes into 12, which is 4. So I can break that up. 2, I can't break up any further. And 4 is a perfect square. Square root of 4 is 2, so that's minus 3 times 2. You can probably do that in your head there. And let's see, so I will have 6 square roots of 6 plus the square root of 4 is 2 times this 2 is 4. So 4 square roots of 3 minus 9 square roots of 2 and minus 6. And none of these radicals are like terms to one another, so I cannot combine them any further, so this would be our answer. So that's how I can deal with kind of adding or multiplying radicals. And the key is that like radicals, I guess I'll write a little fact here, why not? So like radicals have the same index and radicand. So the radicand's the inside. And what do you know, when I wrote it, that r even looks like a square root. So thank you for watching, and then in the next video I'll talk about dividing radicals. Thanks.